and good day, geometry. We continue our exploration of exponents with CO11 dividing by the same base. And similar to CO10, when we multiply by the same base, we're going to start with expanded form, see what's actually happening here. Okay? You do actually, now that I think about it, you do have some experience with this back in CO47 from algebra. So since you all kept your binders from last year, if you need to review, you can go back home, take a look at it, CO47. It's similar stuff. So, Joe. All right, we have 3 to the 5th divided by 3 squared. In expanded form, what that's saying is that we have 5 3's all being multiplied together up top, and 2 3's being multiplied together in the denominator. Now, I wrote these the way that I did for a reason. Because think back to one of like the most basic fundamentals of algebra that you learned. How can we simplify this the way it's written out now in expanded form like this? Drake.
I forgot what it's called, but then we cross out the 3's in the bottom and then 2 3's in the top.
Yeah, why can we cancel out or eliminate one of those groups of 3's? Why is that mathematically legal? Caleb?
If there's 2 of the same numbers, they just cancel out anyways if you added up or times them all by.
What are they? What's 3 divided by 3 equal? 1, right? Or anything divided by itself equals 1. So all these groups of 3's we can cancel out because this equal 1. And then what we're left with is 3 3's in our numerator. The denominator is now a 1 because 1 times 1 equals 1. We don't have to write it anyway because the denominator of 1 is just, don't have to write it. Hidden math, as the first blue section shows back there. But we get 3 cubed as a final answer. Okay. Next one, 6x to the 4th z squared. So we have 6 times x times x times x times x times z times z. In our denominator, we have a 3, and then times x times x. And again, this is intentional, me kind of put my z's with my z's. What can we do? Now that it's written out in expanded form, what can you see here? Peter? We can cancel out 2 pairs of x's because they just equal 1. What else can we do? Drew? 2 z's. What else can we do? There's more. Will? Right. This 6 and 3, they're kind of like, well, not kind of like, they are coefficients, and we can simplify them. 6/3 cancels out to be 2 over 1. So what are we left with? In our numerator, we have our 2, and then 2 x's left. So we have 2x squared. We don't have any more z's. These are gone. They all canceled out. In our denominator, we have a 1, which we don't have to write, but then we have a z. So we have 2x squared over z. And hopefully by writing it out in expanded form, you can kind of see how we got to that. Because if you just look at it, 6x to the 4th z squared over 3x squared z cubed is 2x squared over z, Okay, but expanded form helps us see what can we cancel out, what can we simplify, and what do we have left. Like CO10, we're going to look for a shortcut here, a rule, right? But for right now, expanded form can help us see what's going on. The last one, 9m to the 4th is a 9 times an m times an m times an m times an m, and then a 12 times m in the denominator. What can we do? What can we do? William? Cancel out a pair of m's. Will? Simplify 9/12. We treat it kind of like a fraction, right? 6 divided by 3 worked out evenly in the previous one. This one doesn't. That's okay. What does 9/12 simplify to be? Gino? 3/4. Okay? So then what we're left with, in our numerator, we have that 3. And then m cubed, we have 3 m's left. In our denominator, our m is gone. It canceled out, but we do have that 4. So we get 3m cubed over 4. All right. So from those examples, can you tell me when dividing by the same base, what happens to our coefficients? What happens to our exponents? What happens to the base? That kind of summarizes what's going on here. Because like the last one, we don't want to have to write this out in expanded form every single time. Okay? So what's kind of the shortcut here? What do you see? What patterns, connections? Will? Okay. So the exponents are subtracted, right? In each of these, we ended up with the first one here, 3 cubed. 5 minus 2 equals 3. In the second one, we had x squared. 4 minus 2 is 2. And with the z's, we ended up with z to the first. 3 minus 2 equals 1. But how do you know whether that variable goes in the numerator or the denominator? Because my x's were in the numerator, my z's were in the denominator. How do you know? It's where you have more to start with, right? If you start with 3 z's in the denominator and 2 of them get canceled out, there's still 1 left in the denominator, right? If you've got 4 x's in the numerator and 2 of them cancel out, there are still 2 x's in the numerator, okay? So it's wherever you have more of that variable to start with, that's where it's going to end up in your answer. And then the last one, this is m to the first. Our rule still follows here. 4 minus 1 gives us 3. Those 3 m's are in the numerator because that's where we had more to start with. All right, coefficients or the base? Peter?
The base stays the same.
The base stays the same, just like the last one. Base stays the same. Nothing happens to it. It might get canceled out, so it ends up being gone, but if it's left, it stays the same. How about the coefficients? Drew? Simplified. I call this the 3S rule as of about 2 seconds ago, because I just noticed they all start with S. But yeah, the coefficients are simplified. Sometimes you'd say that the coefficients are divided, but it makes more sense to say simplified because 9 divided by 12, we didn't actually do that, right? We simplified it to be 3/4. So simplified works better than divide. All right, questions on this? Okay, let's do some more practice. Says write each expression in expanded form and then simplify it to be one term. So the first page, I would like you to do it in expanded form first. The second page, you can use the shortcut. Okay. 9 to the 6th over 9 to the 4th. And the reason why I want you to practice this in expanded form first is because inevitably, always, someone's going to just use the shortcut without thinking it through and say, oh, let's see, 9 divided by 9 is 1, and then 6 minus 4 is 2. My answer is 1 squared. But what's wrong with that? Right? Because coefficients are simplified. 9/9 is 1. If that's what you put, then that's why we're doing expanded. Okay, so what's wrong with that? Why is that not the correct answer, Blake? The 9's not a coefficient. The 9 is the base, right? And in this rule, the base stays the same. And if you write it out in expanded form and you do your canceling out, obviously you're not going to put 1 squared as an answer because you don't have any 1's here, right? You've got 9 times 9. Please trust me that after 15 years, I have a sense into how students think, particularly middle schoolers. I was one once, and I did these mistakes. I just thought, oh, I can do this. It's easy. It's fine, right? It's easy to get tripped up when you've got a numerical base like we have here, okay? So take the time to write it in expanded form until you get that practice. 9 is a base, not a coefficient. The base stays the same. C to the 5th over c squared. Cancel out what we can. What are we left with? C cubed. Where are they? In the numerator. So if you want to put c cubed over 1, it's fine, but you don't have to. I hope no one put 1 to the 5th as an answer for the third one here, especially after talking about the first one, right? Because again, here we have that situation where that 2 is not a coefficient. And when you write it out in expanded form, as painful as it is to write out 2 times 2, etc., the 8th power, when you do that, and you cancel out the 2's, you can clearly see you don't have a 1. It's not 1 to the 5th. What do you have? You've got 2 to the 5th remaining. Okay. Let's look at, this next one here. Okay. No coefficients to worry about here. Our base is h. Our exponents are 5 and 7. What's our final answer going to be? H squared, right? But we have 2 h's left, but where are they going to be? The numerator or the denominator? A new voice, perhaps? Slightly used? Mackie?
In the denominator.
Denominator. Why?
Because there's 2 extra and everything else.
That's where you have more to start with, right? And again, if you take the time to put it in expanded form, you can see that. That after we do our canceling out, we have 2 h's left in the denominator. So what is our numerator going to be then? Blake? A 1. 1 over h squared. We had more h's to start with in the denominator, so that's where they're going to end. How are things going? Questions? Thumbs up? All right. Let's look at the second page, because who knows what joys I put on that for you. More of the same, although you do not have to write the expression in expanded form first, thankfully, because that middle one is n to the 100th, y to the 61st. Ain't nobody got time for that. But it's similar things, okay? Coefficients simplified, exponents subtracted, bases stay the same. Then down at the bottom, it says write an expression that would simplify to be the following. So it's kind of like I give you the answer, you give me what the original expression could have been. So for x to the 12th, it could be as simple as x to the 13th over x. You think that plaque falling was just a warning? Just a precursor for the big one? It's just a reminder, get that fixed. Okay. Or you could make it a little more complicated, right? You could do something like, 20x to the 30th, y to the 4th over 20x to the 18th, y to the 4th, right? To where the 20s cancel out completely, the y to the 4th cancel out completely. You've got 12 more x's in the numerator, and that's what you end up with, x to the 12th. So it can be as simple or as advanced as you want it to be, but that's the answer. You give me a potential original expression. Any from the back page, second page, that you would like to see in more detail? Drake.
On the bottom row, the very last, the one to the far right.
That 4n to the 5th times,
Um,
or the 1 over h.
the 4 and the 5.
Are you sure that you haven't had, you already know to always say the last one. It's like you've been here for years. Yeah. Okay. So 4n to the 5th times negative 12n to the 9th over negative 9n squared times 4n to the 4th. We're kind of combining CO10 and CO11 here. So what we're going to have to do is kind of simplify our numerator first by multiplying those coefficients, right? 4 times negative 12, negative 48. Add those powers, n to the 14th. And then we're going to simplify our denominator. Negative 9 times 4 is a negative 36. And then 2 plus 4, add those powers, we get n to the 6th. So before we can go to dividing by the same base, we have to make sure that our numerator and our denominator are in simplest form as well, which actually brings us back to CO10 and multiplying by the same base.
When we get our answer, would both the denominator and the numerator be negative?
Oh, we're not done yet. Oh, no. We don't. The last one is never just a one-step. Simply, yeah, this is why you asked for it, right? So how can we simplify this now? Coefficients of negative 48 and negative 36, yeah. Divide by not only 12, but since they're both negative, those negative signs will cancel out too, right? A negative divided by a negative equals a positive. So the 48 36 simplifies to be 4/3. You divide both by negative 12. And then how many ends and where are they? How many ends do we have left and where are they? Joey?
There's going to be 8 ends left and they'll be on the top.
Yep, because that's where we have more ends to start with. Okay, so 4n to the 8th over 3 will be your final answer. Okay. Don't go ahead and divide 4 and 3 to get 1.3 repeating. And so you shouldn't have an answer like 1.3 repeating n to the 8th. Now that we're in algebra, we deal with improper fractions. If you go to high school and you write an answer like that, and your teacher says, "Who told you to write it like that?" and you name me, I'm throwing you under the bus. I'm saying, that did not come from, no. Okay, I will not be the one held responsible for you putting an answer like that. 4n to the 8th over 3. Yes. It's the same value, but it is an exact answer because I have that repeating sign there. But the notation that we would write that, the acceptable notation would be n in fraction form, like that. 4n to the 8th over 3. Anything else? Okay. Questions, comments, concerns, complaints, comments, congratulations, or criticisms? Yes, Blake? 4? Just everything? Thank you. I've tried hard. Anything else? Drake?
Congratulations on the Packers winning.
Thank you. I had no part in it at all, but Aaron Jones was on my fantasy team, so I guess that's good. Yeah. Yeah. All right. Homework due tomorrow, CO11. That, folks, is how you math.